thank you everyone for coming in. I know it's been an amazing conference so far, so you guys must have caught a lot of stuff. So I appreciate that you guys were able to make the time to come in to listen to our presentation today. The topic is end-to-end machine learning with H2O on Azure. Quick show of hands, how many of you have heard about H2O, Azure AI? OK, there's a few. That's nice. For the rest, who are we? We think of ourselves as an open leader in AI. Our goal is to democratize AI for everyone. What I mean by that is a couple of things. So it's about using open source to sort of, that thing is running before I am ready to go. It's about using open source to democratize and basically set a level playing field for every enterprise. Any enterprise should be able to take the best technology out there and use it for their purposes, be it building applications, doing basic stuff like forecasting, or building AI-generated predictions for any of their purposes, right? The company itself has been around for about 6 years. We have multiple products, and I'll walk through each of them in a minute. We are about 100 employees, headquartered in Mountain View, and we have offices all around the world. Very recently, Gartner named H2O as a leader in the machine learning quadrant. We are right over there. Let's use this so that I don't switch over. On the far right, we are named as the leader with the most completeness of vision. What they mean by that is that our technology and stack was the most forward-looking. And they also named us as a quasi-industry standard because the H2O open source algorithms are being used by other vendors in the quadrant. So we are one of the few companies who wrote their own implementations of algorithms. So we have taken all the most common machine learning algorithms and re-implemented them from scratch to be parallelizable and scalable. And from a developer perspective, we have over 12,500 companies using us on a regular basis, and nearly half of the Fortune 500 companies are also now using us, including a major chunk of the data science community. These are just some of our customers. As you can see from, we are very highly over-indexed on the financial services, insurance, healthcare, retail space, and we work with most of the top banks, top insurance companies, and top healthcare companies. So the question is, what kind of use cases do people use this for, right? So when you look at financial services as a vertical, things like KYC, anti-money laundering, transactional fraud detection of all kinds, real-time targeting, deposit fraud detection, churn. So all the use cases, typically you hear about when you think about machine learning AI, thinking about image recognition, text, NLP kind of problems. We are talking about the boring issues, like the transactional data use cases, the log data, sensor data, IoT data, all of the structured data that people have been collecting forever. What do you do with them? How do you use them to predict fraud, predict next best action, predict who's the best customer in your data, and so on. Same thing with something like healthcare, right? You can do stuff like claim prediction, imaging, personalized drug matching, product recommendation, hospital management, remote patient monitoring, flu season prediction. So this is what people are doing today on a real basis. Like companies like Kaiser, Change Healthcare, Aetna, large hospitals are using this on a regular basis to do these kind of use cases. Telcos are the big play for us, where we can do things like battery failure prediction, resilient networks, avoidable truck roll, customer churn prediction, personalized program recommendations, for example. So again, companies like Comcast, Cisco, large mobile vendors are all using this on a regular basis to do these kind of use cases. So if you're familiar with H2O, you probably used one of our products, these products. We have H2O open source. We have Sparkling Water, which is essentially H2O running on top of Apache Spark. H2O for GPU is our porting of all the H2O algorithms to run on NVIDIA GPUs, which are fully accelerated. And on the far right, we have driverless AI. Far left, we have driverless AI, which is our next generation product that automates the entire machine learning workflow from data ingest, feature engineering, model building, visualization, and interpretations. We do the end-to-end workflow all completely automatically. So that's our next generation product. And all these are available on Azure. So if you are an Azure user, you can use the H2O VM directly, or HDI Sparkling Water, or driverless AI. We're going to focus today on the HDI offering, H2O for Sparkling Water, H2O Sparkling Water on HDInsight, which is basically 100% open source Apache B2 licensed product. All the algorithms are developed by us, and they've been ported over to run on Azure. I don't know why this slide keeps popping over to the next one before I'm ready to do that. So when you take a look at the high-level architecture of the product itself, so we can ingest data from any source you can. Sorry. Whether it's HDFS, S3, Azure Blob Storage, Azure Data Lake, local or SQL databases. Once the data comes into the H2O data frame, sorry, not this. It's popping out to the next slide before I'm ready to do that, even before I hit enter. So, but
slide advancer is only on this back here. It's not on our machine.
oh, okay.
It's okay. No worries. 2 seconds.
All right. Sorry for the technical.
It's okay. We're all technicians. We get it.
Yep.
Hopefully it'll be. Oh, so we're extended right now. So it looks like.
Okay.
So now I extended your display or.
Okay. There you go. Now I should hit. There you go. Perfect. All right. So let me back up for a second. So the H2O VM and Sparkling Water are 100% open source. They are built for data scientists. You can use it through R or Python or Scala or H2O Flow, which is our own notebook interface. Whatever language is preferred, whatever environment is preferable for you. Sorry. And then H2O Driverless AI is available as its own custom GUI that you can use directly through the interface. So when you look at the H2O architecture, when you load data in, everything comes into this in-memory data structure, and this is where the data will reside. And once the data is in this in-memory data structure, you can apply about 80 different functions from basic things like mean, median, merge, joins. You can do basic data merging operations, and you can apply one of the 12 different algorithms that we implemented, which are all fully distributed and parallelized. So if you have data sitting on Hadoop or Spark instance, sorry, you can click twice on this guy. So if I click twice, it stays on the same one. All right, thank you. OK. All right. OK. All right, so this will stay over here. So once the data is in the H2O data frame, you can apply any of the different algorithms that are implemented, and you can use it through R, Python, H2O Flow, or whatever language you prefer. And the real neat thing is once you build a model with H2O, you can get instant Java export. So you can get the code artifact either as a Pojo or as a Mojo. And that can be deployed in either Spark Streaming, Kafka, Storm, or whatever application you build, right? So from an end-to-end perspective, we go from data ingest to model deployment all with the same platform. Okay. So when you look at the H2O algorithms, these are the common algorithms that most people use. Things like GLM, generalized linear models, distributed random forest, gradient boosted trees, deep learning, k-means, PCA, GLM, and autoencoders. A whole bunch of algorithms are all fully implemented and all fully parallelized as well. From a high-level architecture perspective on Spark, what we do is we essentially have the H2O executor running in the same JVM as the Spark executor, which means that the data transformation from a Spark data frame to an H2O data frame is extremely cheap. So you can go back and forth very easily and not have to write to disk or read back from disk each time. And what that means is that because you share the same memory space, you don't have to have a lot of data in memory. So you don't have to have a Spark a data frame and an H2O data frame both at the same time in memory and lose a lot of the memory space. So just to show that in one more way. So essentially, when you have the Spark data frame across your cluster, the H2O data frame will sit in parallel with the, say, Spark executor, and you can do the data transformation back and forth very easily in the Spark cluster. Right? So what that means for you, when you're doing model building, you can use the bring the data into Spark, use Spark SQL or some Spark commands for doing your data munging, use H2O for your model building, and then do the prediction processing back with Spark and H2O together. Or if you want to do data munging operations, you can then bring the data into H2O first as an H2O data frame, apply all of your H2O operations on it, then apply some Spark streaming operations, Spark operations on it, and go back and forth, and then deploy the same thing. Or you want to do stream processing, you can do data munging in Spark, use the model in H2O, and then put the whole thing back together as an entire streaming application with Spark streaming, Storm, or Flink. And the model prediction itself can be done there. So you essentially get a lot of different ways to deploy your model and use Spark plus H2O for your use case. So when you come to H2O plus HDInsight, essentially what you're getting is you are getting the best algorithms, which are the most fastest and highly optimized ones, like GBM, GLRM, K-means, deep learning, ensembles. And you get the power of HDI, which is your fully managed scalable infrastructure all at once from Azure. Okay. So with that, I'm going to jump into the demo real quick and show what that means. Okay. Right. So when you come to the Azure portal itself, you can essentially bring up, search for H2O.ai, and you'll find a bunch of offerings. And this is the offering you're talking about. It's H2O Sparkling Water for HDInsight. So you pick it. You can set up your storage. We work with Spark 2.0, 2.1, and 2.2, all three. And we connect to Azure Data Lake as well as Blob storage. So you pick the storage you want. You do the settings. You define all your stuff, and then once it's up and running, it takes about 25, 30 minutes. You can then essentially go to the URL, which is basically, this is the cluster name that you selected. It's so H2O build in this case. That's my demo instance. And you can come up and see your cluster usage. This is basically the Ambari interface. So right now, none of these things, right? So you can also then go to the same URL /Jupyter tree, and you can essentially come to the Jupyter Notebook. So Jupyter Hub is deployed by default, and you can then start one of these demo scripts, or you can start your own thing. So I have a demo script over here, which we'll walk through, and we'll see what exactly happens. So I'm going to run this, and I'm going to talk through what each of those steps are going to be doing, right? Okay. So first thing is doing is we are configuring the Sparkling Water shell. So Sparkling Water itself is a jar file that gets configured, and this is the command to do that. It's basically a standard Spark. It's submitted as a Spark job. The key thing to remember is we are defining a 21 gig cluster over here. So 21 gigs are assigned to the Sparkling Water cluster, and 3 executors are being picked. So you can have a large Spark cluster, and you can assign a subset of it for a Sparkling Water cluster. Sparkling Water is meant to be highly ephemeral, extremely fast software. So it's not built for resiliency. So you don't want your entire Spark cluster to be mapped to Sparkling Water. You bring Sparkling Water up, run your machine learning jobs, turn it off, and then do stuff with Spark. So once it's up, then you can start doing your work, right? So in this case, we have this data set, which is basically it's actually a retail e-commerce data set from an Amazon Fine Foods review, which was put up in Kaggle. So they had about 500,000 food reviews on Amazon, which we are going to process through. So you can see the H2O cluster is now up, and it has about 24 total cores, and about 55 gigs of total memory are allocated to this. Okay, and the algos that are available are XGBoost, all the algos in the H2O platform. H2O itself has its own AutoML. So if you don't want to pick an algorithm, you can say ask H2O AutoML to run through all the algos. Okay. And then you can also open H2O Flow over here. which is our own notebook interface. So if you don't want to use Jupyter Notebook, you can use H2O interface to upload your own data set, get frames, split frames, merge, build models, and whatever you want, right? So it's up to you. So you get another interface to do all that work. But in this case, we're going to use the Jupyter Notebook to do the work. So you can see the data is being loaded from this blob store over here. And once it's loaded, we are looking at this is a preview of the data set. As you can see, there's a whole bunch of text, free text over here, which tells you a little bit of information on like the header on wonderful, tasty, and then a little bit of description of what the actual food itself was, right? So 500,000 rows, about 10 columns of data. The first thing we're going to do is we're going to import the data and then do a quick preview of the data set, right? So essentially, you have the score, the rating, which is 1 to 5, timestamp, the summary of what the review itself is, and a little bit of an helpfulness indicator that's been loaded. The first thing we're going to do is we're going to take the time column and split it into year, month, day of the week, and hour. So this is what you call feature engineering, right? So you don't just take the time column and apply it. You can split it into different time-based features, and those can be much more effective in helping solve the problem. So that's extremely easy. You just do a time zone function, which is, again, defined by the H2O parameter. And you can essentially create, take the original column and convert it into a day, year, month, year of the week, and so on and so forth. So once you're done, you got these extra additional 5 columns. That makes it 10 columns. And now you can convert this into a Spark data frame. So notice it's essentially as simple as doing as Spark frame. So the reviews data frame, which was a H2O data frame, got converted to Spark data frame almost instantly. So there was no lag because the memory transfer was completely in the same JVM space. Once that's done, you can now take the Spark data frame API and apply a whole bunch of things like you can do averages, you can do Spark SQL, and you can load up the data. You can do some basic visualization, like you can see what's the number of, like you plot the histogram of reviews by year, and as you can see, most of the data is from 2012 and some historical information. So the next thing we're going to do is prepare the data for modeling. And what we do over here is we are going to take the data set and create a score out of it. So we are going to try and predict what the score is based on the actual text of the review, right? So to do that, we are going to use TF-IDF from Spark. So H2O has its own TF-IDF and Word2Vec, but you're going to use Spark's TF-IDF to convert created vectors, and then use H2O's GBM for the modeling, just to show the back and forth between Spark and H2O, right? So we took the original data set, converted the TF-IDF features, applied the transformations, and then we converted that back into an H2O frame. So this is where all the TF-IDF features were created, and this is where we converted back to an H2O data frame. All this happens very simply, right? And we also then can do basic stuff like take numeric data to convert it into categorical and vice versa. So in this case, day of the week and score are categorical factors, so we converted the numeric data into categorical. And once that's done, we do the memory cleanup, and then we are going to basically do a random grid search with some hyperparameter search. And then we ran this whole thing, and let's see. So it ran through the grid search, and the best model is over here. So after running through the grid search, there's some errors. These are not errors. These are basically warnings on deprecation. Basically, some of the APIs have changed. But essentially, the model ran, and it presented a list of models that it ran. So we ran about, basically, in the grid search, about 16 different models were built. And you can look at the results over here. I can also look at the results over from this place. I do a list all models. So you can look at the grid search and the results of the grid search, and you can see the AUC over here. You can get some useful value visualizations. If I click on a point, I can select a point. You can look at all the different thresholds, accuracies, points, and the confusion matrix. So it's a really neat way to look at, get some quick exploration on all the models that you're building. I could also do an AutoML over here, which essentially means that I'm going to just take the data frame. In this case, there is no validation frame, but I can just specify how much time I want to give. I can say that I just want this to run for about 120 seconds. And I can pick to use all the algorithms, or I can exclude. I can say that I don't want deep learning, use everything else. But if I want deep learning, I can leave that as well. But I could leave everything in. And I can ignore just a couple of columns. Well, and then the response column is what I need to pick, right? So I'm going to pick the score as a response column and build a model. And this will run through all the different models I picked in the amount of time I gave it. So if I have a lot of time, this will run through a lot of models and actually give me results. In this case, it ran through a quick set of models. And it's actually trying basic transformations. It's applying some basic feature engineering, doing some analysis. And it's going to build a bunch of models over here. And as the models get built, you can review the leaderboard and pick the best model out of it to deploy. And deploying a model is also extremely easy. I'll show you that in a second here. So when I do list all models, so the models are over here. So the first model already got built. So this is a distributed random forest. So I can take this one model that got built already by the AutoML, and I can basically go and do a preview projo. Right. So OK, this is still getting built, but let me pick another model over here, which already got built. This one over here, yeah. So once a model got built, you can essentially get the scores, and you can basically get the Pojo. So you can download the Pojo, which is the Java code over here, and I can export the model. And so I can take the Java code, which is ready to deploy, and I can put that back into Spark Stream if I want to as well. Okay. And you can essentially then get a sense of what are the most important features for your model, and you can get the deployment code as well and do it. So what we did, just to review, right? We went through, took a data set, loaded up into Spark. We did some data munging on it. We used Spark to do TF-IDF, created the vectors, built a model with H2O, ran AutoML to run through a whole list of models, pick the best model out of it. And then we got the deployment code, which can then be put back into Spark streaming for everyone. So that's kind of your end-to-end story. So if you want to get started, you can pick the H2O offering from the Azure Marketplace. You can also look at the documentation side to try it yourself. There is a really nice blog that was written by the folks at Microsoft, which talks about deploying and operationalizing H2O AI models to Azure. So essentially, you can do the same thing with different ways. You can use a single VM if you want to. You can use an H2O HDI cluster, or you can do Azure Batch. So you can take, if your data size is small, you can use a single VM and quickly do an analysis, get a proof of concept. If you're using large data, you can use either the HDI Sparkling Water cluster, or you can use Azure Batch. And they both have different needs, right? HDI is, of course, fully managed, so it's extremely easy. You don't have to worry about infrastructure. Azure Batch, on the other hand, you have to set it up yourself, but it's super cheap. So if you have long-running jobs, you can use Azure Batch for that. So we personally use a combination of all three. A lot of the proof of value, like immediate experimentation, happens on the single VM. HDI for jobs for customers where we have like large data sitting in Spark. And then Azure Batch for jobs which want to run for like many days, for example. So because it gets really cheap there. So all three options available for batch scoring, for model building, and you can look at what's convenient depending on your use case. So that's all the time I'm already above. Go ahead and evaluate the session if you liked it. Sorry for all the technical difficulties. But thank you. My name is Vinod Iyengar, so I'll be sitting here if you have any questions. And Catherine Camp, she's my partner on the HDI side. She's over here. So if you have any questions about HDI, do ask her as well. Thank you.